Anyone? Did we start this topic on processing technology part 1? Okay, all right. Okay, good. Let me begin the lectures on processing technology part 1. So for subsequent lectures till the end of the semester, we are not going to go into the chemistry or the physical properties of ethanol, or even analysis of it. We are going to concentrate lots more on the processing technology, and also the downstream processing of ethanol products. So can you see my slide now? No? Okay, good. All right. So let me briefly introduce this topic to you. Since we have already covered the industry, give you some background of the palm oil industry, and we also going into topics such as on the compositions, the physical properties, and also the chemical or the degradations and analysis of ethanol products. And now perhaps it's time for us to go into what will be the actual processing for edible oils and fats products. So with that, we will cover three major processing steps involving fats and oil products. So the first part, which is today, we are going to introduce a topic on isolations of oils or the extractions of oils and fats from various raw materials of the biological origin. So it can be from plant or it can be from animal. So, but I will concentrate the lectures on plant-based products, especially on palm oil. Okay. Then we will go into refining process, because upon isolations or extractions of ethanol products, they are not fit for human consumption generally, especially for plant-based products. So we will require some further processing, such as refining processes, in order to make them fit for human consumption. And that process is actually more relevant to food science and technology students, because for isolations of oils or fats or extractions of oils and fats, the finished product, which is usually termed as crude oil or raw oil, they are not fit for human consumption. So therefore, since the finished product is not fit for human consumption, generally we don't regard that process relevant to food science and technology students. And yet, I constantly like to introduce this topic to you in one specific topic for at least 2 to 3 hours, because although the finished product is not fit for human consumption, but eventually this will be the raw material for refining process and subsequent modifications of oils, which is very relevant to food science and technology students. And whenever you join fats and oil industry, such as palm oil or any other soft oil or margarine plant and so on, you are going to perhaps utilize some of this raw material that this particular segment of industry, the extractions of oil, they are the one that provide you the raw materials. So you must be able to understand why the raw material quality is like that. What kind of factors affecting the oil quality during the extraction process. So that is extremely important because then you will know what kind of refining or further modification process that you need to perform on that raw material in order to obtain a type of oil or a series of oils or fats products that are fit for human consumption. So therefore, this first part is going to be the important parts of our this afternoon topics. Then we will go into refining processes, which is right after you come back from your Araya. And for that, once you come back from Raya, the week of starting from 1st of May, which is good for you, it is public holiday Monday, so therefore we will not be able to have both lab and also a lecture schedule. So I will need to replace the class for all of you. We will discuss it, or perhaps I will make announcement in WhatsApp group, see whether I want to make it the week after the 1st of May week, which is perhaps we will have our usual lectures as usual on the 8th of May, and perhaps the evening class we will have online session to replace it. Yeah. So that we can, I will make announcement in the WhatsApp group. So and on the 8th of May we will cover refining processes, and that we will use a palm oil refining as a method or as a subject for us to look into these processes. And then the week after that, we are going to start to cover oil modifications processes, where I will cover major part, but in terms of industrial applications on modifications processes, I will get industry speaker to come over and to share with you those modification processes. Okay, so this will be the major part of the processing and technology sections on FST 4834. So let us take a look at productions of oil. And we can obtain oil from animal kingdom. We can also obtain oil from plant kingdom. From animal kingdoms, of course, we can get it from marine source, seafood product, especially deep sea fishes. And we can also get it from animal, such as we get it from cow like tallow, or pig like lard. So that is actually a big portion. So for animal kingdom, perhaps the larger portions of ethanol going to come from lard. Yeah, I mean from pig, where consumption is very high in many parts of the world. Of course, not for countries such as Malaysia, which we have also majority of our populations are Muslim. So therefore, we don't really go into that detail on lard processing. But in other part of the world, lard is a major fat consumed. All right. Then there is also productions of fruit oil from plant kingdom. And when you talk about fruit, there is two specific type of commercially viable plant that we obtain the oil from, which is oil leaf. We get the oil from mesocarp, and also palm oil. We get the oil from fruit, the oil palm fruits. Yeah, and these two type of fruits, they are going to follow very similar processes in many part of them, but yet they have also huge differentiation because of further refining process. Okay, so a lot of those big volume of olive oil, and it is a very unique product that majority of it we don't go for further refining process. After pressing the oil together with water or moisture from the fruits, then we just centrifuge it or separate it or centrifuge the oil together with water in order for us to separate oil from water, and then we start to pack them and label them as extra virgin or virgin olive oil. And the mesocarp of olive still have some amount of oil that industry will also try to extract using solvent and eventually evaporate off solvent. And that oil will require refining process, such as, for example, neutralizations, bleaching, and deodorizations. And this oil is well, no longer able to be named extra virgin or olive oil. And usually they will just either label it as olive oil, which you can get it from Malaysian market, or sometimes we call it pomace oil, olive oil, POMACE. So I just type it in the chat room. So pomace oil is also a very unique type of oil. And industry usually going to, because the volume is not big, they may want to mix it with virgin olive oil to increase the volume, but they can no longer pack the oil and label it as virgin olive because it has gone through heat processing during the refining process. So, and that type of oil, usually the price will be the cheapest compared to extra virgin or virgin olive oil. So when you go to the market, you can start to observe the labeling of olive oil products. Then you will start to see such a category of product, pomace olive oil, or usually they label it as olive oil without any keyword like extra virgin or virgin. And of course, under fruit oil, we will also have another big group, which is palm oil, which is very close to us. So for this part of lectures, I will also concentrate on palm oil. There is no much meaning for me to teach olive or soybean oil extractions because we hardly have any substantial industry to support graduates to work in that sector. So therefore, we are going to talk more later. We are going to see mainly concentrate on how we can extract crude palm oil from palm fruits. But of course, when you take a look at vegetable oil volume, there's also very huge volume going into seed oil. So these are such as soya bean, sunflower seed. It can be also rapeseed. It can be also corn, cotton seed, sesame, and groundnut, and so on. So they're also going through. There is a requirement for industry to also obtain the crude oil, but their process is very different from olive or palm because we extract the oil from the seed but not the fruits. I hope that you can still recall your biology. I'm sure most of you like biology so much during your secondary or your pre-U program. And You know, fruits and seed is a very distinct properties. Fruits usually having very high moisture content, while seed usually have very low moisture content. So to begin with, for productions of seed oil, usually it will require the use of solvent to do the extractions. And therefore, eventually they will pass through very different path of refining process compared to fruit oil. Okay, so therefore, the refining process for seed-based crude oil, it is usually very different from the one that we use for palm oil, for example. Okay, so first I would like to briefly introduce how we obtain animal fat. There is two type of rendering process, and the extractions of fat from animal kingdom, the process we call rendering. Okay, so what is the Malay word for rendering? I cannot recall. I used to be able to recall the Malay words for rendering, not now. So rendering process is very similar. I think most of us, your mom will have perhaps show you this kind of processes. You chop the adipose tissues of animal into smaller size, and then you put into a hot pan, and then you start to heat it up. Your mom may add a little bit of oil, or usually without oil is also fine. Then eventually the adipose tissues will start to excrete out the oil together with moisture, but moisture or water will be evaporate out because the pan is very hot. So it can be a frying pan, or it can be a normal this shallow pan for heating, and then you are going to get oil leak out or leach out from the adipose tissues, while at the same time you see the adipose tissue going to shrink in size and become what we call graves. And this is usually at the end quite crispy. And those Chinese may have experienced that your mom will keep it, or even you go to a restaurant, they are going to have such a product, those fat graves, and you can add into your dishes during cooking, and it is a little bit crispy, and so on from lard. So, but industry-wise, they are not going to use a hot pan or a fryer because the volume is too small for them to use. They are going to use machine for using wet or dry rendering process. Both are acceptable. Both are usually very efficient to extract the oil from animal fat. But I must also say, if you ask me whether should the industry use dry rendering or wet rendering, there is no specific rules saying that, oh, you should only use wet or dry rendering. But it is usually said that wet rendering temperature is slightly lower than dry rendering. And usually wet rendering, your adipose tissues is not exposed directly to heat or the surface of stainless steel, which is hot. And therefore, it is more suitable for example, if you want to extract fish oil or those fat from poultry like animal fat, chicken fat, where you want to retain some of the chicken aroma or flavor into your fat. And that is more suitable because the temperature of wet rendering is a bit lesser or lower than dry rendering. Okay. So let us take a look at it. The fat melting and rendering process have few important goals. First thing is because it is still you want to remove water. Adipose tissue also containing very high amount of water. So those are white fat is of animal. If you take a look at this particular photo, you will note that the white meat is actually adipose tissues. And this is the right type of meat that you can use it for rendering process. Okay. And because the moisture content is high, you first need to remove water. And then during the removal of water, you will be able to get your protein out of it, oils or fats out of it. And this is very common. And eventually, because there's also protein, there's also solid, there's also fat, there is also water. Usually water eventually evaporate off and left with minute amount of moisture or water. Then you need to separate the oil or fat out of it and then further dry it. And of course, industry sometimes going through sanitations, either through sheaf to sheaf those meat particles which is already burned. Usually because drying rendering process, especially dry rendering, the temperature is a bit high. So if you have a little bit of meat, which is not fat but meat, then they are going to get burned. So those particles, if you do not filter it, then perhaps microbe would like to eat those lean meat portions, or it may not look nice on the fat, which is like lard or tallow, because it is usually white color. So it is easy to see those burnt particles of meat if you don't filter it. So therefore, they may go through the filtration system. Let us briefly go through the process. First, wet rendering. I'll usually show you the design of equipment. So it is similar for both wet and also dry rendering. So first, if you take a look at this, you have adipose tissues, a big part of it. Usually people get it underneath the skin. The portions is usually directly underneath the skin. You have thick layer of fat. And the same thing goes to human. Usually that is underneath our skin is the part that we have the deposit of the fat molecules. And therefore, it is easy for industry to also remove the adipose tissues underneath the skin. And then they are going to grind it, chop it into smaller size before going into a steamer to steam it. So in the steamer, they are going to steam and expand the adipose tissues, and then you have a melting. You are going to pass through the melting vessel to stir it, constantly stir it, because it is expanding. So therefore, eventually, you will be able to excrete out the liquid and oil. And then you go into a decanter to remove the solid particles, then your liquid portions. Your liquid will consist of combinations of perhaps water and oil or the fat from animal, and also some the water may also dissolve some protein as well. And then once you go into decanter is an horizontal centrifuge. Then you will have graves, depending on how you want to keep the grades. Sometimes people go for further drying and keep the grapes and sell it as byproduct. It is crispy portions of it, and it is crispy, sometimes crunchy a bit, and you can repack it. While for wet rendering industry is interested with the liquid portions, the liquid have the valuable fat in it, so they are going to centrifuge again using a separator. Separator and decanter is actually similar principle. They are both centrifuge. It's just separator is a vertical centrifuge, which I already mentioned this before. While decanter, did I mention this before? I don't think so, yeah. It is the other group. Another one is a decanter. Both are centrifuge. So if someone asks you what is the difference between a decanter and separator, decanter is a horizontal centrifuge. So it's a horizontal type, you spin this way, while separator is a vertical type, so you spin vertically. So for a vertical centrifuge, then that functions once they receive the liquid, they are going to spin it and separate the fat out of the sticky water. The water is usually called sticky water because it will contain a substantial amount of protein in it. So that amount of protein, then it can be used as a byproduct for gelatin industry. So industry will extract or collect this sticky water and further evaporate out the water, left with the protein, usually in the form of pectin. So, sorry, in the form of gelatin. And gelatin is also widely used in food and non-food applications, such as for encapsulations of drug or supplement and so on. So while the fat, they will eventually require further filtration system to remove those particles that are not separated, either in the decanter or separator, because those particles are small, tiny protein particles from lean meat that you require filtration so that the fat will look off-white and nice and consumer like the kind of white without light brownish particles or dark color particles in those fat products. Okay, so and this is how wet rendering processes. So you can read my explanations on your own, which what I explained to you, I already mentioned also in the subsequent slides in wording form, in text form. Next is a dry rendering process. If we take a look at this design, you are going to see that they are actually kind of similar to dry rendering. It's just that in that case, there is no direct steaming process. So you still require grinder to reduce the size of adipose tissue to make the extractions of fat more efficient. If you have one big lump of fat, it is usually difficult to extract more fat out of those lump. So then you are going to go into, after you reduce the size, you will go into a disc dryer. So what is a disc dryer? It is still a horizontal kind of rotating, or sometimes it can be also stagnant, but usually they will have rotating. And it is a jacketed disc dryer, so steam will go into the jacketed piping system and transfer the heat to the disc dryer. So the disc dryer is a stainless steel, usually surface, and it's extremely hot. So once adipose tissue touches it, then it is just like a hot pan when your mom cook or do rendering at home to get some lard or to get some tallow out of it. And then you have water evaporate off, but majority of water perhaps still stay inside the adipose tissues. And then they are going to go through, transfer it to a press to squeeze the liquid out of it. Once you squeeze the liquid out of it, then you have those solid like grapes that you can keep, and some protein you can also obtain out of it, but there are still a lot of protein dissolved in the liquid portions if you follow my arrow. And then going through a decanter, horizontal centrifuge, and then you have your fat out of it. So and your discharge of sticky water portions. And the fat sometimes, because horizontal centrifuge is not efficient to remove more moisture, and you are going to pass through another separator to separate additional water, and then pass through the filter to filter out the particles, small particles that cause not pleasant appearance of your animal fat. Especially after cooling, the animal fat will look like candle of white. Then it will have a lot of those brown spot or dark brown spot, which is not nice to look at. All right. So the process is for dry rendering is you are using this dryer to do your process. Okay. So I don't want to go into again wording. So because I already explained to you, I also mentioned about why it is called a decanter. Decanter, which I mentioned just now, is an horizontal centrifuge. Okay, while separator is a vertical centrifuge. I mentioned about filter just now to remove the solid particles out of it. So that is white. That is rendering process for animal kingdom. All right. If you have any questions to ask, you can ask me now on rendering. If not, I will start my next topic on palm oil milling process. Any questions? No? If not, I'll go through the milling process. I will go through the detailed processes, but if first I will introduce the overall process flow in this particular slide on the process flow of palm oil milling. Yeah? If one begin the milling process in palm oil industry, we call extractions of crude oil from palm fruits a milling process. So the factory, we call it mills, MILL. Okay, I just type it in. So you have palm mills, usually very close to plantation site because that is where they get the raw material from, which I already mentioned this when I introduced palm oil industry to all of you. And I mentioned refinery usually close to the port where they can export the finished product very easily. So mill were never close to port because their raw material is palm fruits, just like the arrow that I show it to you now. So therefore, it is all closer to plantation site. If you begin your milling process with 1 ton of fresh fruit bunches, so when you go into industry, sometimes you hear people saying that FFB, FFB. So FFB stands for fresh fruit bunches. So FFB. So if you begin with 1 ton of FFB, so you will ended up getting about roughly about 20% of it as crude palm oil. So you get about 200 to 220, 30 kilogram of oil. So the oil yield from mills usually roughly about 20%. Industry, our government is actually very concerned about this percentage of oil because in a year, our mills process million tons of palm fruits. So even 0.1% increment in the oil extraction rate, it is usually very significant to the industry. So any mills that have very efficient way of extractions, usually bosses are all very happy. Okay. So one particular term that usually you will need to know is industry will start to talk about OER. Let me type OER. I just typed this abbreviation in chat room. Anyone want to let me know what is OER stand for? What is OER? Is oil extraction rate. So Hui Ling is almost there. Instead of organic, it is oil, yeah? Oil extraction rate. So industry is very concerned about OER. Our Malaysia, for many, are you familiar with Rancangan Malaysia, the Malaysian plan? Are you familiar with Rancangan Malaysia? So it is a 5 years plan for our nation. Usually, we are now venturing into RM, so Rancangan Malaysia plan 12, I think. It is from 2021 to 2025. So we are in the middle of RMK 12. So of all previous RMK, I think since RMK 8, it is a 5-year plan. The government is very particular about the way that we can increase OER. So in the meals is always brought down to how efficient based on their OER. So government is going to keep a record, monthly record, and eventually yearly record for each meals and ask them to report OER so that we will know roughly how much of oil the meal managed to extract. So in Peninsula, anyone from Sabah and Sarawak in this particular group? Who is from Sabah or Sarawak? No? We don't have any students? Or at least Alicia is from Sabah or from Sarawak? Alicia, are you with us? Ah, Sarawak. Okay. So for OER, as a very important parameters for meals, sad to say Peninsula is usually relatively lower than Sabah and Sarawak. Sabah and Sarawak sometimes have the OER of about 23%, sometimes people say about 27%, but Peninsula getting lower and lower. Although 20% is kind of we want to achieve, but sometimes meals only achieve about 18 or 19%. That is low. And because of government previously set some restriction, the limit, so if you extract less than that, then sometimes government is going to fine meals because they have lower OER. So that make actually for quite many years bad practice in meals where because they want to show government some data that they have extract more than 20%, so they are going to scoop the crude oil from drainage system, from condensate, and so on. Later, I'm going to share with you how they do it. So they are going to take some of those oil from sludge and put it back to crude oil, and that eventually causes the crude palm oil quality drop drastically because they already mix with some contaminants. Okay, so now government already kind of relaxed in the OER requirement and ask them to collect those additional oil from sludge and so on and don't mix it into crude palm oil or CPO, and they will be able to use this category of oil in oleochemical industry or any other, especially in oleochemical industry where you can eventually turn them into detergent, fatty alcohol for surfactants and so on and so forth. Okay, so from fruit bunches, you are going to go through sterilization process. This is usually the first step. So because anyone see the real FFB before? or touched the real FFB before? No, none of you. Okay. So you have experience looking at the FFB. It is usually big, about 20-30 kilogram, one FFB bunch. Yeah? And inside they have few thousand, 2,000 to 3,000, usually fruitlets, depending on what will be the how mature is the or the age of the tree. The younger tree usually give you slightly smaller bunch, but those already few years trees, then they start to give you quite a big bunch. Yeah? And if you take a look at those fruitlet system, yeah, the fruitlets is actually very difficult to remove from the bunch. You need to twist and twist many times in order to pluck one fruits out of it. So for industry applications, if you ask workers to do one by one, perhaps one bunch will take you whole day, but you still cannot finish remove the fruitlets. So that is not possible because in a day sometimes mills can handle few 100 tons. 1 ton is 1,000 kg. They can handle few hundred tons of FFB. So with that, they require first step sterilization to cook the fruits. To cook the bunch so that during cooking, because if you cook fruits using steam and so on, you are going to know that the tissue is going to get softened, and then it is easy to strip the fruitlet out of it. Okay, so that sterilizations is always the first step of process involved in meals. So then they will go through stripping process. So stripping is just to strip the fruit out of the bunch. So eventually you are going to see you have an empty bunch and also a lot of fruitlets. And these fruitlets, before pressing, to press the crude oil out of it, you will require to do one more step, which is digestion. Why there is the need to do digestions? Because the fruits, if you have touches, if you have ability to see and feel the fruits, it contain mesocarp, which is the majority of it is mesocarp. The thickness maybe depending on how big the fruits, it can be maybe half a centimeter to about a centimeter thickness. And then you are going to see that only the outer layer or maybe a few of from the outer layer of fruit is soft. The inner part is still relatively hard, and the center part you have a shell containing kernel, palm kernel. And that make the extractions of oil eventually during pressing not that efficient because the mesocarp, the inner part of mesocarp is still relatively hard. So what industry will do is they are going to let it pass through a digestion. It's not like our stomach digesting our food. It is also a compartment whereby you introduce steam and plus some blade. They are rotating to cut the surface of fruits so that steam can penetrate into a deeper layer of the mesocarp and cook the mesocarp. Then they are going to press the oil out of it and you obtain a crude oil. And this crude oil is very viscous. I think is, if you ask me, the viscosity may be similar to honey viscosity. And this viscosity is not easy to handle because it is very viscous like honey, but it is not pure like honey. It will contain solid, it will contain the mesocarp fiber, it will contain some sand, some soil, water mixed with it, and therefore it is difficult to remove them very easily. So therefore, they are going to add hot water and eventually screen it to remove the sand or stone, that bigger particles, and then let the mixtures of hot water and oil stay in the clarification process. Under clarification process, they are going to either go through passive clarifications, put into clarification tank to let gravity separate water and oil. So based on your primary science, you know oil is going to stay on top of water. And then after a while, there is two separations, and then you just discard the oil, discard the water at the bottom part and collect the crude oil. And then you get the oil. You may want to go for further drying to dry the oil, and that oil is called a crude palm oil. So crude palm oil usually are free from particles, solid particles, and also free from sand, from fiber. So they just containing crude form, usually water also very low because you go through drying process. And while the water portions is going to become a wastewater, which we call sludge, SLUDGE, and sludge is usually also close to volume like crude palm oil or CPO, about 180 kilo per 1 ton of FFB. You will get about almost close to 18 to 20% of sludge. So volume of sludge is huge. So you can imagine if, let's say, a plant or mills are processing 100 tons of FFB per day. Only 100 tons is considered very relatively small, not very big. In a day, they will have to treat 180 kilo times with 100 times with 100. So it is almost like 18 tons, 18,000 kilo of sludge that you need to so-called treat before you can discard it to our drainage system or river. So therefore, in the mills, you always see very big size of pool or pond, POND. And this pond is usually required by DOE or Department of Environment for mills to capture the sludge, for them to treat the sludge. And it is usually not only one pond. You will have 2, 3, 4, depending on how big the capacity of your mills. And the first pond is usually very dark brown color sludge, very dirty sludge. And this is actually very dense in nutrients, and the sludge will require further treatment. Industry put microbe into it to let the microbe eat those nutrients. It can be carbohydrate, protein, and so on. They also have some residue of oil, usually about less than 2-3% of the oil still in it. And then they are going to degrade it. And you always see them sometimes cover it with a canvas to capture the methane gas generated. And the methane gas will be used as a cooking gas for plantation site household. The workers, they are going to provide them housing area, and then they are going to build piping system to channel natural, so-called natural gas for them to use. And these are considered a recovery of energy out of it. Okay, while some of the mills will have another segment which we call palm kernel line, not all mills will have this particular segment, yeah, that they can handle kernel. So usually those plant that we call integrated plant, they are going to have both crude oil, this particular flow from sterilizations up to drying and separations to obtain crude oil and sludge. There is also one more path after pressing of crude oil. You will have the press kit. The press kit will have the center part of kernel, and then you can eventually crack the nuts or kernel in order, or the shell, in order to obtain the nuts or kernel. So not all mills will have this particular additional part. If those mills have this additional part, it is called an integrated plant. Okay. So during pressing, my next question is, during pressing, can a mill press the oil out from mesocarp and at the same time crush the shell at the center of the fruit, and then also squeeze the oil out of the kernel? Can they do this together during pressing? Mesocarp oil and the kernel oil being squeezed out together. Can they do that? Why not? Why not? If exam questions are this, how are you going to answer in final exam? Can in the mills during pressing process? Yes, they can produce palm kernel oil separately. Why must they produce palm kernel oil separately? If let's say this is your answer, and my next questions that I ask in exam is, why is that oil? Why must we produce palm kernel oil separately? Why can't we mix palm oil together with palm kernel oil? If you go into industry, if industry asks you these questions, how are you going to answer? Help save the byproduct waste. We can also squeeze it out together so there will be no waste, right? We squeeze the kernel oil out of it and mix it with palm from crude oil. Why industry cannot accept this particular practice? They must have additional line to handle kernel. Or go back to compositions of fats and oil. Okay. So when I teach you, so I hope that you will also gain and link what I have shared with you before. If you look at compositions of oil, palm kernel oil fall under which category of oil? Palm oil is a palmitic oil. Palm kernel oil, Myristic, yes, they have myristic, but majority of it is C8, C12. What is C12? Myristic is C14. Oh, it's also unique. Yes, it is a lauric oil. So lauric oil is a unique oil, cannot be mixed because palm oil is a palmitic oil. So once you mix, then this oil can no longer call palm oil. You can also call them palm kernel oil. There is no standards have these two mixing of oil as a commodity. So therefore, they cannot be mixed. So during pressing, you must understand in the mill, during pressing, you cannot crush the kernel shell. Once you crush it, that's it. Your oil cannot be used for further processing. So they must be separate. So I'm also going to share with you. So I stay in this particular flow chart for a long period of time because I want you to see that overview. So subsequent slides, I'm going to explain these processes in a more detailed manner. Okay. So I may go back again to this particular flow chart, but if possible, I will skip this and will go into each one of it. Sterilization, stripping, what happened, digestions, what happened, pressing, what happened, and so on. Okay. So in the meals, we have raw materials of meal, which is FFB. That is actually the raw materials. Extractions of palm oil from FFB is a mechanical process, which means that it's a physical process. So modern palm oil mill today is based on predominantly the concept developed by a report we call Mongana report. Did I share with you Mongana report before? Is this the first time you heard about Mongana report? Yes or no? Is this the first time Mongana report? During 1950s, I think 1955, if I'm not mistaken. None of us were born there during that period of time because during that time there is no Malaysia yet. We have yet to achieve our independence. So who actually helped out with this Mongana report? Anyone want to try? Mongana report? No idea? Yes or no? No. Okay. Then I explain a little bit of history. Okay, we go back to a bit of history. Malaysia, we are British colonized country. So, and when British decided to give us our independence, and they already observed that our country is not going to survive very well after independence. If we still base our economy on the two major commodity during that time, based on your sejarah or history, what is actually the two major commodity before we achieve our independence that support our economy? Anyone want to try? Getah, yes. One more? Yes, Timah, two. We base our economy on tin mining and also rubber. But during that time, the tin reserved in Malaysia is almost depleting. While at the same time, rubber, natural rubber is receiving huge competitions from the newly developed synthetic rubber. So British, in actual fact, to me, they gave us such an easy way to achieve our independence is mainly because they do not see great value in Malaysia or holding to Malaysia anymore. So, but they also kind of so-called a little bit kind to us and start to develop a good report so that they can pass it to us upon our independence. Mm, to see whether is there any other agricultural activity or any other industry that we can do in order to sustain Malaysia during that time. So, and this is the report they developed, and in this particular report, especially mentions that there is an ability to so-called venture into palm oil industries because palm during that time is an ornamental tree. It's not have never been used or for agriculture so-called products and producing oil out of it. But people are aware that the fruits having substantial amount of oil. So we based on this particular Mongana report and we develop our first meal, and up to now, majority of the meals in Malaysia or even in the world is still based on the predominantly the concept developed by Mongana reports. Of course, now far more advanced equipment being highly efficient machine being developed, but the processes is almost still utilize the flow provided by Mongana report. So back to this particular lecture. An average size of FFB is about 20 to 30 kg, and therefore plantations is always almost most of the time we see male workers. Female is relatively difficult to take up 20 to 30 kilo of fruits and put it in a truck. So therefore it is quite labor intensive. But nowadays there are some automations running in some of the commercial plantations to remove the fruits by machine and then put it in a truck and deliver to the mills within short period of time. And then each of these bunch, which I mentioned, is about 1,500 to 2,000 fruits. And then the FFB are harvested usually and delivered to the mill if possible during the same day. The longer you let the fruits stay on the ground, like now we are having a heat wave and where the temperatures outside is extremely high. The ground temperature, I think now on the ground, I'm talking about ground temperature. It is not the air temperature. Air is about 30 to 35 degrees Celsius, but ground temperature now can perhaps reach about 50, 60 degree. Ground touches the soil. So at that high temperature, if you have the fruits that touches the ground, because fruits are usually have certain height, and they will have certain part of the fruits injured, and the lipase is going to be excreted out, and lipase like to find their best friend, which is triacylglycerol. They are going to hydrolyze triacylglycerol and eventually causes increase in FFA. So the longer you let the injured fruits stay on the ground, then eventually higher FFA is going to be developed in the fruits. And during pressing, you are going to have higher FFA and then much higher losses during refining process. And this is not going to bring any goods to the quality of oil after refining. So industry always try their very best to process the fruits as soon as possible. But you must also understand this perhaps is a little bit easy for well-organized plantations. But for small size plantations owned by smallholders, anyone here own oil palm plantations? Anyone, your parents own oil palm plantations? Anyone? No. Okay. So if you have a small plantations, then usually it is your fruits will always most of the time stay on the ground for slightly longer period of time because your plantations may be small. In a day you harvest maybe 10 fruits, and it is not possible for you to get transport to come into your plantations and collect it unless that those many small neighboring smallholders join effort in a day will get a lorry to come and then collect from different smallholders and ship it to the mill. If not, they are going to stay on the ground for quite some time, and this eventually will degrade the fruits and causes poor quality CPO. Even for big plantations, I must also let you know, just for your knowledge, even big plantations sometimes cannot achieve those golden period. The best is 6 to 8 hours you must process the fruits. But I must tell you, for big plantations, they cannot achieve even 24 hours after harvesting. They must process the fruits. They cannot achieve that. So that will not be able to create high quality oil. And eventually, without high quality oil, those refined oil will have higher losses and poorer quality. And this is the sad phenomena. Okay, big plantations like Sam Dabi also nowadays only have about 1 to 2% of crude, very good quality crude palm oil, and they are not going into our consumptions. We normally export it for infant formula for higher pricing, and therefore we are eating poorer quality oil from already many years. Okay, because the good quality one we export it. All right. So the quality of crude oil usually dependent on how well we take care of the fruits. So if you visit a mills, if you have a chance to visit the mills, you're going to see sometimes the fruits delivered by lorry from plantation to the mills, they are all poured into ground again. And this will cause further injury and stay on the ground for a long time until they are fully utilize it for the milling process. Okay, so mills have a capacity varies about 60 to 100 tons per hour. That is actually a big volume. So if a mill's running about 8 hours, only one shift of about 8 hours, so in a day, a mill can swallow about 800 tons of FFB. So if it is running at about 16 hours, two shifts, then it can swallow about 1,600 tons of FFB. So we are talking about 1,600 tons. So that is how big the volume a meals can handle in a day. Yeah? So the process is sterilizations, which I already mentioned, to cook the fruits, and then stripping to remove the fruitlets, digestions to make sure the mesocarp is fully cooked and softened, then pressing to get the crude oil, and then crude oil mixed with hot water to go for clarifications to separate particles and water out of the crude oil, and crude oil going through perhaps purifications and drying to further dry it in order to obtain what we call a dry CPO. And for storage and eventually based on demand, we can sell it as CPO or we can sell it to refinery. Okay. So I already mentioned also there may be a kernel line, which kernel lines is not necessary. All mills will have it, but if they have it, then it is called an integrated plant, so that you can obtain palm kernel. Okay, the kernel, the nuts. These nuts you can actually chew it. It is like chewing matured coconut meat. A similar taste because it is a similar category of oil, is a lauric oil like coconut. Okay, so the meat actually tastes a little bit like matured coconut meat, the hard coconut, not the kelapa muda meat. All right. So the first step is sterilization. So this is the first step. To main purpose is actually strippability of fruits. But in an exam, I always like to ask these questions. Not necessarily it will come out in final exam, but I just give you a hint. I always like to ask sterilization process. Beside to cook the bunch so that we can easily remove the fruits, there's actually one very important properties that we want to achieve. which is to inactivate, or another important function that to inactivate the enzymes of lipase in order to prevent buildup of FFA. The higher your FFA, eventually you are going to have much worse or higher losses of oil, because FFA means that you already hydrolyzed the DAG. So your DAG hydrolyzed, so you have also increase of FFA, DAG, also MAG. But oil, refined one, we want to have 95 to 99% of DAG. We don't want to have FFA, all right? So there's two major functions in in sterilizations. First, to strip the fruitlets out of it, out of the bunch, and also to inactivate enzyme because temperature is very high. And then it also helps you to soften the fruit mesocarp. Usually it's about you cook the fruits under huge amount of steam for about 1 to 1.5 hours, depending on the design of sterilizer. So you are going to take the fruits, put them in cages. Cages, you can imagine like your commuter or your MRT cars. So they are of slightly similar size, or similar system, that you are going to see mills. In the mills, they have like railway track. The track is for those cage to move around to receive the fruits, to receive the bunches and then channel it to sterilizer. So they are going to use usually about each ton of FFB or bunch, you will require about 140 kilogram of steam. So steam consumption is high. So to make the milling process more energy saving, so you need to generate a lot of steam. So where do you get the fuel from to generate steam? From boiler? So eventually you're going to see you can also burn the empty bunches in that boiler, so that they will generate heat to boil additional water to generate the steam for sterilization process. So this is a typical conventional sterilizer. So if you ask me what is the size of this sterilizer, I must tell you, I can go in very easily with my height. So which means that you can walk in through this sterilizer. Nowadays, all sterilizers have a proper safety feature. So it can be a continuous sterilizer, but you still need to close it once. Maybe they can accept maybe 4 cages, or they can accept, like you can imagine a train, you can accept 4 cars into this particular sterilizer, and they're going to close both sides and then start to supply steam. But long time ago, during the early stage of development of sterilizer, we have issues of workers moving in to sterilizer, but there is no alarm system being built, and then cage go in, close the sterilizer, supply steam. So what will happen to these workers still inside? What will happen to these workers? I'm pretty sure you see a lot of horror movie before in your lifetime. So what will happen to these workers in the sterilizer under such a high temperature for 1 to 1.5 hours, supplied of steam? Can you imagine? Of course, the person will not be able to survive. But what exactly happened is basically melt totally. You can't even see bone. Okay, it melt under high temperature. But now sterilizer are all having all kind of safety feature that it will not operate if they know there's foreign object inside it. Okay, so horizontal sterilizer is still very much preferred. But from time to time, people start to introduce vertical tilting sterilizer, but these are not commercially viable to me. Okay, so it is still a conventional sterilizer system. So if you want to see the design of sterilizer, this is a sterilizer. Can you see the, follow my arrow, yeah? Can you see the so-called like a railway track system built? Yes, and can you see the cage that I mentioned? It is like macam gerabak kereta api, all right, like a train car, okay? So each one can house certain amount of fruits, and then you channel it, they will have truck. So mills always have truck, okay? They have truck, and it's very easy to see the movement because the workers will channel it through this particular. So there's one side, if you see my arrow, there's empty cage, and this cage are all filled with fruits. I mean, FFB venture into it. All right. Then after cooking process, okay, you will need to strip the fruits. If you look at the top part of the bunch, you see now there is no fruits. So these are called EFB. If someone say, oh, this is EFB, so how much is your EFB and so on? So they are referring to empty fruit bunch. Previously, when I was very young, perhaps in primary school, I can see that for meals, it's easy to identify meals because surrounding the meals, they have a lot of EFB. They have a lot of empty fruit bunches. So they all piled up because you can imagine that in a day, let's say a meals is running on 2 shifts. Let's say they handle 1,600 tons of FFB. They will have a lot of EFB at the end. So previously, no one wants those EFB, so they're going to put it surrounding the meal. So sometimes I must tell you, depending on the age of the meal, so let's say the meal is already running for years, you are going to see it piled up, sometimes even like mountain, higher than the factory itself, the meals. So, but now you hardly see a single EFB in any meals. They are highly sought materials. For what purpose? Why they are highly sought materials now? Not even Malaysia, but around the world, people are looking for it. Why are they looking for it? Any idea? No? It is used as a biomass for burning. So people can chop it into smaller size, grind to small size, and make it into pellet that you can use it in your barbecue cooking, and also being used for generate energy. So I have a group of friends that in Pasir Gudang, they have built factory with dynamo. You know dynamo, right? You study physics. Dynamo to generate energy, supplying the electricity to surrounding factory in Pasir Gudang. They are using burning process using this particular pellets from EFB. So EFB is now heavily high demand. So last time mills need to beg people to take the EFB and throw it somewhere else. And now they are selling it 1 ton, few hundred ringgit. So now it is a very high price material and it is not sufficient. Yeah. So now let us take a look at stripping. So that is usually a drum stripper is used so that you push the sterilized bunch into drum, and then the drum will rotate. The drum have some opening to collect the fruits, and then the empty bunch still inside. So if you take a look at this, this is actually the drum. So it is cylindrical. It's like a vertical decanter. Sorry, a horizontal decanter. So they're going to turn, and then you're going to, if you follow my arrow, can you see those opening there? There is an opening where the fruitlets will drop, and at the bottom there is hopper to hop it, while the EFB, empty fruit bunch, going to be on top of it. All right. So can you imagine the process now for stripping? So you will have your fruitlets going into this while the bunches is on top. Then bunch can be removed and people are all waiting, queuing up to buy your bunch. But your workers will still need to take a look at it because sometimes there is also some fruits still attached to it, especially for big bunches. So these are what we call a hard bunch, or usually we call it hard bunch. In this particular slide, you have the keyword that I use my arrow now. The last paragraph is hard bunch. So there's actually some fruitlets still attached to it. So which means that it is usually considered not fully cooked. So therefore it is still difficult to remove. So your workers must have one station there, although you don't need, but because of hard bunches, if you accidentally you don't see it and a lot of those hard bunches are there, but you throw it and sell it to people, then you lost your oil yield. So what happened is they are going to take the hard bunch, throw it back to the cage, move it back together with any other FFB or fresh fruit bunches and cook again. All right. So the stripping process is important. So usually we will not be able to store, to have an efficient stripping process. So you cannot have 2 liter cooked bunches inside the stripper and let it stir for long period of time, because then you will have also injury to the fruits, and sometimes before going into press, the oil sometimes leak out and absorbed by those empty bunches. So therefore, irregular feeding of stripper sometimes they must be also avoided. And sterilizations also sometimes play an important role. We don't want to overcook the fruits so that it is too soft, and eventually during the sterilizations, after sterilizations, you open up the sterilizer, you see on the ground, because steam is already condensed into water, you see on the ground there's a lot of oil together with water, steam water, and then which means that it's overcooked, it's too soft, the oil leak out from the meso cup. So you must also be a bit careful about that. So if you take a look at the fruits itself, this is cross sections of a fruit. Then they have mesocarp, which is quite thick, and then shell, a thin layer of shell. This thin layer of shell is actually quite hard. It's like a mini coconut, you know. So when I say it is like a mini coconut, which means that it's like a coconut shell together. Inside that is coconut meat. So this inside is kernel. Okay, you can imagine. So then they will pass through dissections and pressing. So the fruits in a digester, which I already mentioned, they are going to heat up the fruits so that to make sure that the pericarp is significantly so-called soften, so that we can make sure that the mesocarp is kind of, not to say totally detached, but it's softened up to the pericarp. If you look at my arrow here, my cursor now, then you can take a look at it. So usually in the digester, if in the question I ask you, exam questions, the functions of digester, why there is a need, because you want to make sure that the fruits are reheated to loosen the pericarp. Okay, so you have like stirring arm and then stirring together with supplying steam, because the stirring arm is going to cut the fruits. Okay, and then the steam will go in and cook eventually. Yeah. So this is a typical design of the digester. You're going to have fruitlets, no longer have the bunch, only fruits, and then rotate, and they're going to cut the mesocarp so that the steam will penetrate inside. So this is a digester and then a press. Okay, this is a pressing, to press. So digester is usually kept in full and rotate, and then the fruit is going to pass through a screw press. So it's going to have, it's a horizontal screw press. It's going to press. We also have this screw press, a miniature of this screw press for coconut milk or santan press. You can put in your grated coconut and then you get your santan out of it. It's a screw press system. In the lab, engineering lab, we have one unit. If you have a chance to look into it, to go into engineering lab, you can ask lab assistant, you say, Prof. Tan mentioned there is a screw press for santan. If you want to take a look, then you can take a look at the design. It is a screw press design. Then industry use it also for extracting of crude oil. So you are going to have a mixture of oil, water, press, cake fiber, and so on. And then some mills will require double pressing so that they have more oil being absorbed, being extracted out of the fiber or mesocarp. Right after that, you will have, because the crude oil I keep mentioning is very viscous like honey, you cannot, but the particles are still attached to it. Can you imagine you have particles still attached to honey and soil still attached to honey? How are you going to remove the small stone or sand out of honey? That is actually quite difficult. Even you ask gravity to help you, gravity can't do much. So industry, what they do is that they are going to add hot water, mix it with hot water, dilute it a bit, and put it in clarification tank. The clarification tank, if you look at mills, the tank is huge. Capacity can be filled 1,000 tons depending on the capacity. There are many of these tanks. This is based on a passive clarification separation technique. Yeah, so this is based on gravity. After you mix the very high viscosity crude oil with hot water, then you're going to let it stay in those clarification tank or settling tank. Based on gravity, water will move down. They will drag together with them some sand and so on, while oil is going to stay float on top of it. So, and then eventually you're going to remove the bottom part of water and eventually take a sheave to pass through the oil. The oil will pass through, and then whatever solid that you have will stay on top of the sheave. Just like you can imagine, like your ground coffee, you pour hot water, but you don't want to have the ground coffee into your coffee, so you use a sheave to remove the ground coffee. The similar, almost similar process, yeah, for clarification. So oil mixtures together with hot water usually require heat up to about 85 to 60 in the clarification tank. Let it set for 1 to 3 hours. So to let the gravity, you basically asking gravity, hey, help me to do separation. So gravity based on density difference, so they are going to separate it accordingly. So oil will be on the top, you can skip it off, while eventually going into drying in a drum dryer, and then the crude oil can be obtained, stored, and then you can sell it a CPO form, or you can sell it to refinery for further refining process. Okay. So, but sometimes industry don't like to use settling tank or clarification tank because it is rather passive. You need to wait for 1 to 3 hours to let everything separate into their positions accordingly. Then they use a decanter, pass through a decanter, just like the one that we see in wet or dry rendering. It's a horizontal centrifuge in order to separate. So with that, you tend to get cleaner water because you can separate solid out of it. So the water, the waste or the sludge is usually a bit cleaner. Okay, you have slightly lower portions of your sludge. In mills, they call also the sludge palm oil mill effluents. So I am sure you have never heard about this, but I typed the abbreviation form. If you work in palm oil industry, especially in the mill, they may call it POME. So from time to time, if you even now you Google POME, they are going to also address it is palm oil mill effluent. So it is actually sludge. Okay, so when you are using a decanter, you tend to get slightly reduced amount of sludge or POME. So therefore, you require less effort to do treatments of POME. Okay, and but although treatment cost is significantly, water treatment cost is significantly reduced, but one of the disadvantages of using it is at the cost of maintenance is very high. I'm not sure you know the decanter design. It is many discs that join together. Uh, the disc is stainless steel disc. So when you have solid, especially sand, centrifuge at very high speed, the sand will touch the disc and the disc will get dent because the speed is very high. It's like a bullet. The disc is a thin layer of stainless steel, so bullet may pass through it. Yeah, although you have a steel, but bullet can still pass through. So you can imagine it like many bullets passing through for many times. So therefore, the disc will get dented, and dented. And from time to time, you need to replace the disc. Sometimes the disc, depending on the capacity of the decanter, a disc can cost you a few thousand ringgit. So if you have 50, 100 discs that join together in a big decanter, you can imagine cost to remove the disc. So sometimes some people say that the cost to remove the disc is far more than the treatment costs for POME. So up to individual mills, some don't want to use a decanter, prefer to use the passive clarifications in a clarification tank or settling tank, but some prefer to use decanter because they don't have to wait for 1 to 3 hours. Okay, so oil losses in mills is very high. So, but it always vary on from mills to mills depending on how efficient the mills efficiency of the mill. So the main oil losses in exam, I usually like to ask these questions. What will be the area whereby we can see losses of oil? It can be sterilizer, condensate, which I already mentioned. It can also empty bunches can absorb because they are fibrous. They can absorb a lot of oil and pull a lot of oil out of fruits. Fruit losses in untrapped bunches or what we call hard bunch. Press cake, always pressing cannot be 100% efficient. You will have 1 to few percentage of oil still in the fiber. And of course, nuts and also sludge will also have oil attached to it. And overripe bunches usually lost more oil during sterilizations because they are already very soft. And during sterilization process, it will incur what do you call it, leaching out of oil together with water during cooking. You can imagine the fruits become so soft, so all the liquid squeeze out so easily. If you imagine the fruits, so that is those problem on oil losses. Okay, so therefore in plantation they cannot accept harvesting overripe bunches. They are going to fine the workers, deduct their gaji because they overlook on overripe bunches. Okay, so I'm going to stop here. It's already 3:40. We take up our schedule. You have any questions that you would like to ask me before I end my lecture? We have a short part. I mean, we have another small portions that we can handle it right after your Raya. Okay, we were going to have our lectures on the 8th of May again. So if there is no questions, you are clear with my lectures, I'm going to end my session here. For those celebrating Raya very soon, I think most likely it's going to be on Saturday, although some people say maybe on Friday. I would like to wish all of you and your family happy Selamat Hari Raya. And for those going back, of course, all of you going to go back just now. All of you inform me that you are going to head home. So have a safe journey back home. So take good care and see you right after Raya. Okay, so I will see you on the 8th of May. Yeah.